Hey guys, this is Mr. Torres. I wanted to do a quick video to go over some of the information that we've been going over this week. I know that we've shared a lot of information over the last 3 to 4 days. Just keep in mind that if this was a regular school year, that would have been 6 to 8 days. Okay. Some of the things that you have to remember are these key terms that I put on this page right here. Okay. Undefined terms, you need to know what are they and how to name them. What is a point? How do we name a point? What is a line? How do we name a line? What's a plane? What's a segment? What's array? All of those things you need to be able to recognize and know how to name them and know how to use them. Okay? You need to know what these are, all these definitions, and what they look like. So what is an angle? What is a vertex? What do they look like? Okay, so again, like a point, you have a point, that could be point A. A line, it's an infinite many number of points, and you name it using 2 points on that line. That's line BC, or with a single lowercase letter. So line BC would have those symbols. Okay, a line segment is just between 2 points, not the whole thing, but just between 2 points. If I put another point over here and call this point X, the space between B and X would be segment BX. Okay, so over here this could be segment BX. Array, well, the difference between a line and a segment and array is that array does go on forever in one direction. It does not go on forever in both directions like the line did, just one direction. And we always start our name with our endpoint. Our endpoint is point B, so we name it BX. If there was another point over here, then that could be array BM. It's the same exact one as that one. Those two are the same. Okay? And then a plane is just a flat surface. It'll look like something like that. And it has a bunch of points, a bunch of lines. And you can name it by three non-collinear points on the plane, or by a single capital letter that's not attached to a point. So for example, this could be called plane ABC, plane CDM. The only thing that it would not be called, you cannot call it plane CDE, because CDE are what we call collinear. Okay, collinear points right here. Collinear points are points that are on the same line, and if you see all three of those points are on the same line, you cannot name a plane using collinear points. Okay, you need to know what an angle looks like. An angle looks like that. It's created by two rays that share a common point, or common endpoint, which is called the vertex. Okay, you should know what parallel lines look like, what perpendicular lines look like. We talked about collinear. Coplanar points would be all these points that are on the same plane. See if I can get this to work. Points A, B, C, D, E, M. All of those points are coplanar. They're all a part of plane P. Okay. Midpoint. If you have a segment AB, the midpoint of that segment, not only is it the point in the middle, but it's the point that splits the segment into two congruent parts. So segment AM is congruent to segment BM, because point M is the midpoint. M is the midpoint. And congruence, it just means that they are, that's a fancy word for equal. And congruence is this symbol, an equal sign with a squiggly line. You need to make sure you know all those. And then we talked about all these other things. We talked about the properties of equality, and then we talked about properties of congruence. The properties of equalities: addition, subtraction, multiplication, division. Those are the ones you use every day when you're adding and subtracting equations. The distributive property, you guys know what that is. Substitution, we've used in a couple of examples today. You solve for a variable, then you substitute it back in. And then the symmetric, reflexive, and transitive property are the only three properties that can be used for equality and for congruence. Okay? And your homework tonight had, the problems that we did in class, how to deal with those properties. And then you have postulates, and the only postulate we really talked about has been the segment addition postulate. And the segment addition postulate says, hey, if segment AB is this whole segment, then the length of segment AM plus the length of segment MB should equal AB. Okay? That's what the segment addition postulate says, that those have to add up to the larger of the segments. Okay? And I wanted to go over some problems that are straight from the homework that we've been working on. Okay? The first one I want to go over is this problem right here, which asks you to write a proof for that algebraic problem. Okay, so we're going to start with our given, which is the 5x plus 20 over 4 equals 15. That's our given. And then algebraically, I would have to multiply both sides by 4. Multiply both sides by 4 by the multiplication property. Okay, that would have been step number 2. Step number 3 is when we actually simplify it and make those 4's go away. And 15 times 4 is what, 60? So that was simplify. And then from there, you would continue solving your equation. Subtract 20 from both sides, so 5x plus 20 minus 20 equals 60 minus 20. And then 5x equals 40. So this up here was the subtraction property. And this again was simplifying. You always simplify after you apply the addition, subtraction, multiplication, or division property. Okay, and then the last thing you would have to do would be to divide. So 5x divided by 5 equals 40 divided by 5, because you applied the division property to both sides. And then you solve x equals 40. That was now because you simplify. Okay, so we need to be able to do those types of proofs during solving the algebraic equation, and just writing out the steps as to, or the justifications as to why we can do that. Okay, I will go over this proof in a second that relates to that. I want to go over one of the problems that we were working on in class today. And this is the problem we were working on in class today. And it says that if S is on segment RT, so here is segment RT, and S is a part of that segment, and it is between it, and our S is 16, ST is 2x, and then it says, hey, RT, which is the whole thing, equals 5x plus 10. Find the value of x. Okay, well, if I use the segment addition postulate, I can say 16 plus 2x. Again, that's this 16 plus this 2x. Well, that should equal the entire segment, which is what RT was. This entire segment RT, which was 5x plus 10. So 5x plus 10. So now what we got to do is solve. Subtract 2x, subtract 2x. 16 equals 3x plus 10. And then we would go ahead and subtract 10, subtract 10. 6 equals 3x. And then divide by 3. Divide by 3, and x equals 2. Now, the problem was asking you to solve for the value of x and the length of ST. ST is that. So what do I do with that x now? We're going to substitute. ST equals 2x. So ST equals 2 times 2, which is 4. Okay? You have to be able to do those types of problems. And then last but not least, here is our proof, the proof that it was part of your homework. I want to be able to do one of the problems so you guys are following along with what we're doing. Okay? It says, given AB equals CD, prove AC equals BD. So step 1, it's right there, right here, says given. So step 1 is a given. Step 2, they're saying, hey, use the reflexive property. What can I use the reflexive property for that will allow me to then bring in the fact that AB plus BC would equal BC plus CD? I'm not sure. I'm not sure yet what I have to do there. The reflexive property tells me that something is equal to itself. So you know what? I'm going to go ahead and say BC equals itself. And that's the reflexive property. Why? Hey, because you know what? Both of these brought in BC. Okay? They added BC to that. And since BC is equal to itself by the reflexive property, you can say that. And they added BC to both sides, and that's by the addition property. Again, that's the addition property that said, hey, since BC is just a number and it's equal to itself, then I can add that to both sides of my original equation. Okay? And then AB plus BC equals AC. So segment AB added to segment BC gave me the entire segment AC. Well, you know what? That's the segment addition postulate. That's too thick. Let's erase that. Segment addition postulate allows you to add smaller segments instead of equal to the larger one. And that's the same thing I did over here. BC plus CD equals BD. And then they just want me to substitute. Okay? They want me to substitute. They want me to say that, hey, my last statement should always say what's being asked to prove. We are asked to prove AC equals BD. AC equals BD. AC equals BD. Well, if AC equals AB plus BC and AB plus BC also equals BC plus BD, what they're doing is they're substituting this in here, and what they're doing, this BD down here, this BD right here, they are taking and substituting it for that. Since AC equals AB plus BC and BD equals BC plus CD, then they should equal each other by using the substitution property. Okay? So guys, come tomorrow with questions. Okay, come tomorrow with questions, and that way you guys will be ready to take your quest this weekend. Okay, you guys have a good day.